All right. Hi, my name is Dhruv Parekh. I am the Senior Azure Platform Engineer at EDF Energy, and today I will be talking to you about automating beyond Terraform. So my hope is that by the end of this presentation, I would have successfully convinced you that there is just a little bit more to automating than just loads of Terraform and YAML code. And we're going to visualize this in the shape of a house. Now, it's not the most exciting house because this house is actually made of, well, Terraform. And whilst that might not be the most exciting house, thank you, this house still has structure, and that structure is, well, you can live in it, sure, but it's not fully maintained. You're still going to need running water, and you're still going to need electricity. Essentially, you're going to need the foundations, and that foundation is automation. And the message is that Terraform builds the frame, the structure of the house, but without the running water and the electricity, you're going to have no foundation to keep the house maintained. So what does that actually look like? When we think of DevOps automation, we usually think Terraform, pipelines, Kubernetes, clusters, and just loads and loads of inline scripts. When in reality, if that's all you ever focus on, you miss out on the true beauty of true automation. And that comes in the flavor of removing friction from the entire life cycle. It allows you to gather requirements and monitor and learn from production environments. So my hope is that by the end of this presentation, we're going to have learned how you can drive real business value through going beyond Terraform and learning how to use end-to-end flows to drive real business value. So automating for business value. This starts with thinking in systems and not scripts. You see, the problem is with scripts, they are tactile and they're very static. If you end up just throwing scripts after scripts after scripts at a problem, you end up with islands of automation. And when you end up on just islands of automation, you end up with pieces of code that don't talk to each other. You end up with pieces of clever code that don't scale with each other. And that helps absolutely no one and doesn't solve any problems whatsoever. Instead, we have to think in systems, because systems are strategic. They allow our teams to work in automated flows. So before writing any lines of code, we need to ask ourselves, what outcomes are we actually trying to achieve? Is it a faster release cycle for understanding how we can learn from production to gather requirements to improve our services? Are we trying to achieve a stronger compliance? At EDF Energy, we have to deal with a lot of compliance, and auditing can take months if you're not careful. And so having it implemented from the beginning is extremely important. Or is it something like consistency and standardization? Something as simple as naming conventions can go a very long way. And each of these points actually lead you on your own and on their own individual automation journey. And so what's next after that? After deciding what outcome you want, you can then start to map the end-to-end flow from idea to code to monitoring. If you're using this as a deployment process, you can start to identify bottlenecks. You can see where systems are slowing down, and you can see where human intervention is needed for automation. So you can see where manual processes can be replaced by automation. And here's the real thing. It's in the design. So when we're automating, automation shouldn't be bolted in. It should be designed in from the get-go. It should be repeatable. You should make sure that all your security isn't leaving you open to more vulnerabilities and that you're covering them in your blueprints from the get-go. And as I mentioned before, compliance. It's extremely important, especially if you're in a very high regulated zone. And so thinking big picture is really important in DevOps engineering. If we think about DevOps engineering as a technical challenge, actually the challenge isn't really that technical. It's more of a mindset shift. We have to start asking questions such as, how does this fit into the wider delivery pipeline? How does it impact security, compliance, and cost visibility? And how does it make your life easier, not just for engineers, but also for product owners, auditors, and leadership? And if you're someone who's transitioning from a mid-level to senior engineer, answering these sorts of questions are really important, because chances are, if you're going for a senior level position, you're going to have to know your technical knowledge anyway. And so what it's actually going to be about is how can you think outside the box, and how can you make life easier, not just for yourself, but also for your stakeholders. And so there's a couple ways in which we can achieve that. And I've got it in four flavors here. First one is anticipate scale. Don't think about the 10 users that you have today. Think about what it's going to look like in 10 years' time when you've got 10,000 users. Make sure that your modules can accommodate for that. Think holistically. You need an ecosystem where each one of your components in IAC, from the Terraform structure you have, can all talk together. And embed governance early. The last thing you want is having users that are overprivileged from day dot, then having to take that privilege away from them 5 years later, because then they're going to question, why are you taking this privilege away from me? Is it a trust issue? No, it's just because you didn't need that privilege in the first place, and it's to do with least privilege. And so embedding governance early will save you a lot of hassle in the long run. And prioritize reusability. Sorry, give me a second here. So when we think big picture, let me just, it's not working, that's okay. When we think big picture, we really have to take a step back and zoom out, because you have to understand each component and module holistically, and also individually how they work in your end-to-end flow. Some of the best DevOps engineers that I know, whilst they are technical, they are also critical thinkers, they are outside the box thinkers, and on top of all of that, they are system designers. They are able to create a system and have it run smooth like butter, because they understand the end-to-end flow. So now we're going to bring this to life a bit with some real-life examples. This is primarily in Azure. That was a bit too much AWS in the last talk. So let's get straight into it. The first one here is Azure tagging subscriptions using a function app. So the challenge here was we had thousands of repositories in GitHub. We have hundreds of subscriptions in Azure, and no consistent naming conventions whatsoever. And there were teams that needed to have only the networking portion of the repo replicated, so they could build on top of that. Now, you might be able to do this if you've got 10, 15 repos and be absolutely fine. But if you're dealing with hundreds of repositories and subscriptions, suddenly the task becomes a lot more arduous to search and find the exact ones that you need. And so the approach for this was to treat it as a catalog and routing problem, not a one-off script. This is something that is going to happen and occur daily. We were going to standardize discovery, matching, publication, and feedback loops. So a lot of the results that were pulled out and the data that was pulled out as to what was matched, which subscription was matched to which repository, has been published onto a Confluence page that is automated, so users can go to one unified place to find it. And then also building confidence scores and guardrails before automating absolutely anything. And this one is really important because it might sound a bit backwards, not automating anything before having guardrails. But in truth, if you start automating something and you don't know what it does, or you haven't put any guardrails in it, and you let that run in prod, you're just asking for a world of hurt. And so it's best to put guardrails in first before automating or writing absolutely anything. And so this was the solution. It was to write a function app that calls a GitHub API that can crawl through our Azure tenant and then tag the subscription with a URL to the GitHub repo, and then also at the same time update the Confluence page. And this is what it looked like. So I have had to blur out quite a few things here. So otherwise I'll get very told off. But as you can see here, we are looking for a direct match for the subscription. It's finding the resource group and the repository, and then it grabs the URL, and then it will update the subscription with a name and value, networking repo and URL. And then again, sorry, I might as well just made the entire screen black, but it's getting the subscription name, saying whether it's got a networking repo, and then grabbing the networking repo URL. Now, the business value in this is that when you come to shifting left, users can now have one unified place to gather their resources and find the correct repo that they need to replicate. Example number 2 is a really simple one, something which probably everyone can find if you just take a step back and look at your end-to-end flow. This one was for data gathering for over 1,000 different VMs. And it was well over 1,000 VMs that were gathering the same data every single month, repeating it every single month. Generally, rule of thumb is if you can access the data through the portal, chances are you can create a script which does the same thing. Now, it doesn't sound very flashy, but I use PowerShell to do this. You could use Python, you could use Bash. I found that in Azure, PowerShell was the way forward just because it was a lot quicker when processing the information, for whatever reason that is. I'm not sure why. And so we had a PowerShell script that would run on a cron tab at the end of every month and gather virtual machine data, and then have that script run in the Azure CLI and output it into a CSV file in Excel. But we can take that a step further as well. You can utilize that CSV file and pass it into a database, and then use Power BI to refine that information and have a unified place again for your stakeholders to view past data of virtual machines and current data of virtual machines. And notice how none of this used Terraform, but it's still automation and it still brings a lot of business value. This next one actually is a little challenge for everyone. So on the left here, well, on your right, are some components that build a virtual machine. Can anyone tell me which order is correct in order to build that virtual machine?
VNet, subnet, VM, storage VM.
Yeah, pretty much. And that's exactly what this is about. It's about dependencies. It goes VNet, subnet, storage, VM. And the reason I'm explaining this is because orchestrator pipelines are an extremely I'd say, underrated feature for DevOps engineering and automation. And the challenge here was that different teams had their own pipelines and resources with their own dependencies. And you'll notice this was specifically for disaster recovery. And so imagine a disaster recovery situation and everything goes down. We were simulating a situation where the tenant goes completely bust and the subscription is no longer there. We have to rebuild everything from scratch. If we had to do exactly this and deploy an order, well, you need to know the order. And this, sure, is quite simple. But when you have different teams that have their own versions of this, so if we were to zoom out again and think, well, maybe we've got a DevOps team, we've got a platform team, and we've got a SecOps team. The DevOps team might be building the DevOps team might be building the storage accounts and the state files. The platform team might be building out the virtual machines and the key vaults, and the security team might be building out the firewalls and routing tables. If you try doing all of that and getting all those teams to work in conjunction with each other during a disaster recovery situation, unless you've got really well planned out runbooks, you're gonna put yourself in a world full of pain. And so the answer to that is orchestrated pipelines. In ADO, you can have jobs and steps that allow you to create dependencies for different stages of your Terraform code and for your pipeline structure. And so orchestrated pipelines are essentially supposed to reflect the dependencies that exist in your environment. And so that actually brings us to the end of the presentation. These are just some of the key points which you talked about. And if there is one thing that I would have you all take away from this, is to go into automation with a think big mindset. Thank you for listening. Open to questions.
When you're, did you find any concerns setting up guardrails before introducing this automation?
The question was, did I find any limitations introducing guardrails before automating? The limitations of setting up guardrails without any automation is that if you have as many processes, so if we were to think about the different teams that are involved, so maybe you've got a SecOps team, platform team, and a DevOps team. If you're trying to implement guardrails on the fly as you're mid-deployment, it's going to really, you're going to find it to be quite a sticky situation in the sense that you're going to be hopping in and out of different deployments. You're going to be having to cancel deployments and put guardrails in, or maybe it's too late and it's actually already destroyed something, or it's overwritten something else. Yeah.
So you're pulling the data and storing in the CSV file, right? So like that CSV file you are like placing in your local machine or where?
The question is
Display in that Power BI dashboard.
Yeah.
So you are integrating Power BI with CSV file, or you are putting all the data to database then integrating with Power BI?
Yes, yeah, exactly. So that's exactly how it works. Yeah. So the CSV file that is created as an output is passed into a database, which can be linked to a Power BI script. Yeah.
Sort of like talk on it, but lots of different levels of engineers here, from lead level to juniors and whatever else. You've gone to a senior role, as you mentioned at the start, quite recently, last year or so-ish.
Yeah.
Saying that. What was your biggest challenge in sort of making that jump up to a senior role?
The biggest challenge is actually, I would say let's go back a bit, because it was this. It was understanding how to make life easier for stakeholders. I think one of the biggest challenges is being able to take that mental step back and really being able to see the bigger picture. But once you can understand once you can understand the end-to-end flows, you will start to be able to answer these questions of how to make life easier for engineers, mostly for yourself as well. One of the key things to do as a DevOps engineer is to make your life as easy as possible. I mean, to some degree, you end up putting yourself out of a job.
That's how I got to my current role. I just want to say, I was head of DevOps, did DevOps, so yeah.
Yeah,
Putting yourself out of a job is a good career practice.
it really is.
So just as driven by the business.
Oh, sorry, I think we had one question here first.
Yeah, I'll try to be quick. Sort of an extension of this sort of big picture thinking. Like, what helped you kind of get more into that mindset? Because I think, at least for myself, when I see a problem, it's easy to sort of localize your mind and just be like, sort of tunnel vision it.
Yeah.
Like, I want to just solve this. What helps you like zoom out a bit?
Sometimes it's just looking at Morpheus. But the serious answer is, I'll give you my story of how I started to think big. Sure thing. So the question was, how can I, as a DevOps engineer, start thinking more big picture? And how can you get into that mind state of thinking big picture? And so I'll tell you a quick story of how I started thinking big picture. And it was actually through a different principal engineer that I was working with at one of my previous roles. And I would hand him my scripts, and he would just hand them back to me and say, think big picture. And I would just get really annoyed as well. I was like, what do you mean? And he would say to me, well, we're not just deploying this VM for this one client. Eventually, we're going to have to scale out, right? We're going to have to anticipate the scale. We're not just going to build our module to accommodate for one virtual machine or one SQL server. We're going to have to accommodate for the module for multiple of them. So you're going to have one server with multiple databases in it, because guess what? You're going to have multiple clients. And so it's really taking these 4 points and thinking holistically in the sense of everything you build, or your infrastructure as code, or the Terraform modules, they should be part of an ecosystem. I mentioned before that you'll have you might find yourself on an island of automation where everything is separated from each other. You really don't want to find yourself there. And if you do, then just try and create those links, right? Try and link your scripts together, make them do more for you.
That's a super important point. There's a technique called systems thinking, okay, which is how to try and think about things in a non-reductive way. How do they interoperate as a system? How do things reinforce each other and work against each other to create a cohesive system? And I've always found that really, really useful. It's like, where does this plug into the overall system, and what are the drivers into that overall system?
Thanks. Yes.
I was just going to ask, you mentioned stakeholders. I'm just wondering, how is this process sold to your stakeholders, or vice versa? I'm not sure that can really be answered.
Yeah. No. So how can this process help us with pleasing stakeholders, essentially?
Well, it's more the other way around. Like, are they happy with it?
Are stakeholders happy with big picture thinking? My knee-jerk reaction is to say yes, because if I struggle to think of a scenario where a stakeholder would come to me and say, "Why have you built for a scalable solution?" Or why have you embedded governance and security early on? It's more pleasing for a stakeholder to hear these things, and they can definitely find comfort in knowing that you're running automation scripts in prod with the correct guardrails, and that you're not just going to destroy absolutely everything.
How iterative is that process? How much of this is driven by them rather than by you?
How much of that is driven by them rather than us? So let's go back again to this one. So organizations and stakeholders usually start at ideas and work their way to outcomes through this, right? They start with asking, what outcomes are we trying to achieve? And those outcomes may be put into Jira boards or into sprints, right? I put release cycle, stronger compliance, and consistency and standardization as just almost placeholders. They actually come in the shape of features and releases, right? And those are things which initially are most of the time set out by stakeholders. So to a degree, you could say, well, this is where the stakeholder starts, but it's important to understand the entire end-to-end flow. Any more questions?
Imagine you've used Azure apps for Azure Functions. Have you used the Flux consumption funds for this and like maximize the cost efficiency?
Oh yeah, it costs about £6 a year to run it.
How reliable they are?
So for my script in particular, it hasn't failed yet. So, but it would depend on the compute that you're using, the task that you're actually trying to accomplish. For example, if it is something which is running, if it's a script that's running for, I don't know, 3 hours in a function app, you may, and if it's doing a lot of API calls, you may need something a bit more than that tier.
Running the script in the version.
Pardon?
Where exactly we're running the script?
Where are we running the script? So a function app runs in the Azure portal, and it can run. It just automates a run. You can set time triggers for it. It can be triggered through a URL. It can be triggered in a lot of ways, but essentially it just runs in the Azure portal.
How long has this journey taken for you to kind of get to this like big thinking, getting the stakeholders buy-in on this? Because I'm assuming that setting guardrails first and then starting to automate is obviously takes longer. It may be the more safe way to do it, but if it's anything like me, that everyone wants what they wanted yesterday, not today.
Oh yeah.
So
Yeah, no, that's
how has that journey taken you?
It's so I've been doing DevOps engineering just now for about coming up to 5 years, which granted isn't a lot of time to push for a senior role, and so in truth the learning curve has been kind of like that, when I would recommend more of a understand these sorts of processes from the get-go. I started off in a grad scheme straight out of uni, and from there it was just learning through a lot of mistakes. A lot of mistakes.
Any other questions? Last one?
Going back to your big mechanism at the very beginning, what do you think your stakeholders are going to look for next in terms of automation? What's the evolution path for automation going forward?
Okay, so the question is, where is automation going next, in terms of think big? If I was to take a step back and think, what is the next step for automation? I would say it's to do with governance. And the reason I say it's to do with governance is because whilst a lot of people are able to do the technical work, a lot of the long and drawn out processes are all governance related. And so if I think there was one thing that's going to evolve and probably needs to evolve, it's how we deal with the governance early on. Because processes still can take up to 3 months just to get something approved, especially if it's in, for example, the nuclear space.
Awesome.
Cool. Thank you.